NFPA 70E does not address neutral conductor sizing. The National Fire Protection Association 70E, or NFPA 70E, is a standard for electrical safety in the workplace. It focuses primarily on protecting employees from electrical hazards such as shock, arc flash, and arc blast. It outlines safe work practices, personal protective equipment requirements, and training needed for electrical workers. Because NFPA 70E's main focus is electrical safety, it doesn't delve into the details of electrical system design or installation. This includes topics like neutral conductor sizing. To find information on neutral conductor sizing, you should consult the National Electrical Code, or NEC, which is also known as NFPA 70. The NEC provides comprehensive guidelines for electrical installations, including conductor sizing requirements. Within the NEC, several sections are relevant to neutral conductor sizing. You'll need to understand these sections to ensure proper and safe electrical installations. Firstly, Article 220 of the NEC covers branch circuit, feeder, and service calculations. This article provides the general requirements for calculating the load on a circuit, which is the foundation for determining the appropriate conductor size. It includes methods for calculating both the demand load and the continuous load. Secondly, Section 220.61 specifically addresses the sizing of the neutral conductor for household ranges and electric clothes dryers. It allows for a demand factor of 70% to be applied to the range load when calculating the neutral conductor size. This is because ranges and dryers typically do not draw the full calculated load on all phases simultaneously. Thirdly, Section 250.24 covers grounding electrode conductor sizing. While not directly related to neutral conductor sizing, it is important to ensure the grounding electrode conductor is adequately sized for safety. This section provides tables and guidelines for selecting the appropriate size based on the size of the service entrance conductors. Fourthly, Section 310.15 and the accompanying tables provide the ampacity of conductors. Ampacity refers to the current carrying capacity of a conductor under specific conditions. These tables are crucial for selecting the correct conductor size based on the calculated load and the type of insulation. Fifthly, Chapter 9 of the NEC contains examples of load calculations, which can be helpful in understanding the application of the code requirements for neutral conductor sizing. These examples illustrate how to apply the various sections of the code to different types of electrical installations. In addition to these specific sections, it is important to understand the general principles of electrical circuit design when sizing neutral conductors. The neutral conductor carries the imbalanced current in a three-wire circuit. In a balanced three-phase system, the neutral conductor theoretically carries no current. However, in practice, there is always some imbalance due to variations in the loads on each phase. The NEC requires that the neutral conductor be sized to carry the maximum unbalanced load. To determine the unbalanced load, you need to calculate the load on each phase and then determine the difference between the largest phase load and the sum of the other phase loads. This difference is the maximum unbalanced load that the neutral conductor must be able to carry. There are some specific situations where the neutral conductor must be sized larger than the calculated unbalanced load. One such situation is when the circuit serves nonlinear loads, such as electronic equipment. Nonlinear loads generate harmonic currents, which can cause the neutral conductor to overheat if it is not adequately sized. The NEC requires that the neutral conductor be sized at 200% of the calculated load for circuits serving a significant amount of nonlinear loads. Another situation where the neutral conductor may need to be oversized is when it is run in a conduit with other current-carrying conductors. The heat generated by the other conductors can reduce the ampacity of the neutral conductor. In this case, the neutral conductor may need to be derated according to the ampacity correction factors in the NEC. It is important to consult with a qualified electrical engineer or electrician when designing and installing electrical systems. They can help you to ensure that the neutral conductors are properly sized and that the electrical system meets all applicable code requirements. Understanding the specific requirements for neutral conductor sizing can be complex, but it is essential for ensuring the safety and reliability of electrical systems. By consulting the NEC and other relevant standards, you can ensure that your electrical installations are in compliance with the code and that they are safe for people and property. Remember to always follow the latest edition of the NEC and any applicable local codes. These codes are updated regularly to reflect new technologies and best practices in electrical safety. Always prioritize safety when working with electricity. If you are not qualified to perform electrical work, hire a licensed electrician. Electricity can be dangerous, and it is important to take all necessary precautions to avoid injury or property damage. Proper neutral conductor sizing is vital for preventing overheating, voltage drops, and other electrical problems. It also helps to ensure the proper operation of electrical equipment and to protect against electrical shock hazards. By following the guidelines in the NEC, you can help to create a safe and reliable electrical system. Additionally, proper grounding is an important aspect of electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and de-energize the circuit in the event of a fault. The NEC requires that the grounding system be properly sized and installed to ensure that it can effectively carry fault current. Understanding the relationship between neutral conductors, grounding conductors, and the overall electrical system is essential for electrical safety. By following the NEC and other relevant standards, you can help to create a safe and reliable electrical environment. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrical engineer or electrician before designing or installing electrical systems. Ignoring these safety guidelines can result in serious injuries or even death. The calculations involved in neutral conductor sizing can be complex, but they are essential for ensuring the safety and reliability of electrical systems. By understanding the NEC requirements and applying them correctly, you can help to create a safe and code-compliant electrical installation. Always remember to double-check your work and to verify your calculations before energizing any electrical circuits. A mistake in neutral conductor sizing can have serious consequences, so it is important to be thorough and accurate. Also, it's important to differentiate between the neutral conductor and the grounding conductor. The neutral conductor carries the unbalanced current in a circuit during normal operation. The grounding conductor, on the other hand, is intended to provide a path for fault current to flow back to the source in the event of a fault. The neutral conductor is typically a white or grey wire, while the grounding conductor is typically a green or bare wire. The neutral conductor is connected to the neutral point of the electrical system, while the grounding conductor is connected to the earth. It is important to keep these two conductors separate and distinct, as they serve different functions. Improper connections between the neutral and grounding conductors can create dangerous conditions and can increase the risk of electrical shock. Therefore, be sure to follow the NEC guidelines for separating these conductors and for making proper connections. The NEC also provides requirements for the physical protection of conductors. Conductors must be protected from physical damage such as abrasion, impact, and exposure to moisture. The type of protection required depends on the location of the conductors and the type of environment. For example, conductors installed in wet locations must be protected by a waterproof raceway or cable. Conductors installed in areas subject to physical damage must be protected by a rigid conduit or other suitable means. It is important to select the appropriate type of protection for the conductors to ensure their long-term reliability and safety. When selecting conductors, it is also important to consider the ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. The NEC provides ampacity correction factors to account for the effects of ambient temperature. These correction factors must be applied when sizing conductors to ensure that they can safely carry the load at the expected ambient temperature. Ignoring the effects of ambient temperature can lead to conductor overheating and failure. Additionally, the NEC provides requirements for the identification of conductors. Conductors must be identified by color coding or other means to indicate their function. For example, the neutral conductor is typically identified by a white or grey color. The grounding conductor is typically identified by a green or bare color. The ungrounded conductors are typically identified by black, red, or blue colors. Proper identification of conductors is essential for safety and for troubleshooting electrical circuits. Failure to properly identify conductors can lead to confusion and can increase the risk of electrical shock. Furthermore, the NEC provides requirements for the installation of conductors in raceways. Raceways are enclosed channels that provide physical protection and support for conductors. The type of raceway used depends on the location of the conductors and the type of environment. Common types of raceways include conduit tubing and cable trays. The NEC specifies a maximum number of conductors that can be installed in a raceway of a given size. This is to prevent overcrowding and overheating of the conductors. It is important to follow the NEC guidelines for raceway fill to ensure the safety and reliability of the electrical system. Finally, remember that electrical codes and standards are constantly evolving. It is important to stay up to date on the latest changes to the NEC and other relevant codes. This can be done by attending training courses, reading industry publications, and consulting with qualified electrical professionals. By staying informed, you can ensure that your electrical installations are safe, code-compliant, and reliable. Remember to consult the most recent edition of the NEC and local codes for the most accurate and up-to-date information. Electrical work can be dangerous, so it's always best to consult with a qualified electrician if you're unsure about any aspect of electrical installation or repair. Safe electrical practices are crucial for protecting yourself and others from electrical hazards. Always prioritize safety when working with electricity.